Hello everyone, I am Reshma Totare, working as Assistant Professor in AISSMS IOIT. In today's session, we will discuss about Bresenham line drawing algorithm. Bresenham's line drawing algorithm uses only integer addition and subtraction and multiplication by 2. Computer can perform the operations of integer and addition subtraction very rapidly. It is an efficient method for scan converting straight lines. The basic principle of Bresenham line drawing algorithm is to select the optimum raster location to represent the straight line. To accomplish this, the algorithm always increments either x or y by 1 unit depending on the slope of the line. The increment in the other variable is determined by examining the distance between the actual time location and the nearest pixel. This distance is a decision variable or error. Here in the figure, the line does not pass through all raster points, that means pixels. It passes through raster point 0, 0, this is the first pixel, and subsequently crosses the 3 pixels. Here B is the one vertex which is present on the right side of the 0, 0. The values are 1, 0. One more pixel A, which is the closest to the line, vertex A, whose values are 1, 1. But here B is closer to the line as compared to A. The second vertex C and D is closer to the line than C. C values are 2, 0, D values are 2, 1. It is seen that the intercept of the line with line x equal to 1 is closer to the line y equal to 0, that is pixel 1, 0, than line y equal to 1, that is pixel 1, 1. Raster point 1, 0 better to represent the path of the line than at 1, 1. Error or decision variable. Here, if you are comparing vertex A and B, distance above the line, that means vertex A, and the distance in between the line and the vertex B is a distance B, dB. dB minus dA or dA minus dB, distance above minus distance below or distance below minus distance above, is the error or decision variable. If the value of E is greater than 0, that means pixel above is closest to the true line, and E, that means dB, E is less than 0, that means dB is less than dA, then the pixel below the line is closer to the line. The error term or the decision variable calculation is based on the formula E is equal to 2 into del y minus del x. Now we'll discuss Bresenham line drawing algorithm in detail. To draw any type of line, the basic requirement is first and the last point x and y values. The values are not equal, then only we can draw the line. If both the vertices values are same, then plot the pixel, point and exit. In second step, calculate del x and del y. Find out the absolute value of x2 minus x1 and absolute value of y2 minus y1. Initialize the starting point. First pixel which is given for the line drawing operation, plot that pixel x1, y1. In fourth step, find out the sign. Sign function returns the value based on the result. That means if the result is negative, it will return us the result as a -1. Result is a 0, it returns the result as a 0. If the result is positive, greater than 0, then sign function returns as the result as a 1. Step 5, if del y value is greater than del x, then set the exchange flag to 1, or else exchange value is 0. Calculate the decision variable or error variable value with the formula 2 into del y minus del x. Value of decision variable or error to compensate for non-zero intercept. Iteration starts with 1. E value, error or decision variable, is greater than or equal to 0, that means positive or 0, and if the flag exchange the value is equal to 1, then increase the value of x with S1. S1 we have calculated here in step number 4. Else increase the value of y with the help of S2 that we have calculated in a step 4 with sine function. And then calculate the value of a, e or decision variable with formula e is equal to e minus 2 into del x. If e value is negative, then don't go in a step number 8. We can directly execute step number 9. In step 9, check the flag value. If the flag is 1, then increase the value of y with S2, else increase the value of x with S1. Again calculate the decision variable value with the help of formula e is equal to e plus 2 into del y. When the value of e is positive and equal to 0, we have to execute the step number 8 as well as 9. But if the e value is negative, then only execute step number 9. Plot the pixel xy, increase the value of I for second iteration till iteration I value is less than del x. We have to execute step number 8 and 9 depending on the e result again and again. Finally, end. We will get all the pixels to plot a line to display the line on the screen. Thank you.